Hello, my name is Kelly Goetsch. Thank you for joining my session. My session is titled Why GraphQL is the Glue for Composable Commerce. Quick background on me. I started my career with ATG, which was the leading commerce platform back in the 90s. So that's how I got my start. Then went to Oracle as a product manager in their Cloud Application Foundation group, and later led microservices. And I've now been at commercetools now for 5 years, where I am CPO. And commercetools is perfectly at the intersection of what I love professionally, which is commerce, cloud, and microservices. Last year, I wrote GraphQL for modern commerce. So GraphQL is near and dear to my heart. All right, REST, for better or worse. REST is an architectural style for exchanging data between systems. It's not a standard. It's not formally documented. It's not a specification. It's more of a style. And it was created by Roy Fielding in 2000 in his PhD dissertation. And even he has said repeatedly over the years that he's getting frustrated by what is actually called an API, a REST API, because everybody just takes whatever they have and they put that REST label on top of it. REST itself is great. And REST done in a pure style is really well done. But what passes as REST these days is it's basically RPC. It doesn't even count. So he's the first to rail against that and how frustrating it is. And composable commerce is a term that was coined by Gartner in 2019, and it describes the ability to consume APIs from either different in-house microservices and or different third-party SaaS applications. So you compose an experience using APIs from different sources, and those APIs are backed by microservices typically. So in a composable commerce architecture, you might get your core commerce engine from commercetools. You might get your CMS from Amplience, for example, or Content Stack. You get your search engine from Constructor or Algolia, for example. But you get your different APIs from different vendors. And then there are some things in-house, for example, loyalty, that you might want to build yourself. But the key here is you're composing your experience. You're not just buying a big off-the-shelf solution for everything. REST is great, as I mentioned, but again, there are issues with it. The first is overfetching. And I'll give you an example. If you're on an Apple Watch and you want to retrieve a product detail page, you only might need to retrieve 2 attributes or 3 attributes, right? You're going to want to retrieve the name of the product, maybe the price, maybe an image. That's it. But if you're on a full desktop website, you're going to want to retrieve potentially hundreds of attributes. And when you call the API, you then have to put intelligence into the client by asking exactly which fields are required. So you have to call APIs and request specific fields. And to make matters worse, because REST is not a formal standard or a specification, different APIs have different requirements for how that data is retrieved. So the format for how you retrieve specific fields from different APIs varies pretty substantially. And that puts a lot of logic into the hands of the client-side developers, which can be quite difficult. The second issue is underfetching. So an example here is, let's say you want to render a product detail page. A product detail page requires that you first retrieve the orders, and then once you look into the orders, then you can retrieve the products. And then once you retrieve the products, then you can retrieve the prices for those products. So there's a hierarchy there, right? And you have to retrieve lots of data, but you have to do it serially. So you have to retrieve orders, and then you have to retrieve products, and then you have to retrieve prices. So now you're at 3 separate synchronous calls that are stacked up against each other. And that becomes really difficult from a performance standpoint to optimize. So that's obviously a problem there. And I'll talk about how you'd fix that with REST more in a second. The third issue is just a complete lack of standardization. And again, REST is great, but REST is more of an architectural style as opposed to an actual standard or specification. So there's no way for a client developer to know what APIs are available or what fields are available or how you call and request specific fields only. There are multiple levels. It's called the maturity model. It's actually called the Richardson maturity model of APIs, where you specify how you make links and references between API calls. And that's a pretty broad spectrum as well. So there's a lot of variability out there. And if you're doing composable commerce, you're calling APIs from many, many different vendors. And all of those vendors are potentially implementing these APIs very differently. So just saying that it's a REST API doesn't really mean anything at all. And then fourth, there's a lack of discoverability. And what that means is there's no central registry. There's no IDE where you can do auto completion of any sort. You don't know what fields are available. And that's just because there's an API sitting there and the client doesn't know what that API is or how to call it or anything of that sort. So there's no introspection or discoverability, or you don't know what APIs are there or how to call them. And again, that puts a lot of work on the front end client side developers. Next is how you actually hack this stuff together and fix it for REST. The first option is you can call each API separately. And what that means is you have a serial chaining of calls. So you call the customer API, and then you call the order API, and then you call the product API. And the example of our product detail page. That works. Especially if there's no latency involved. And if you can do that calling from the server side, it's better, but you still have challenges doing that. It still gets difficult. Another thing that a lot of organizations do is they create an aggregator, otherwise known as a backend for front end. And the example here is, let's say you have an API that you build and you make it available at /iPhone/category detail API. And the example there is now you have an API that you call that perfectly returns only the data for that client for that specific function. So here you're marrying an iPhone, which is the view, and you're also pairing that with category detail, right, which is what you're trying to retrieve, or order detail, or whatever it happens to be. And the challenge there is now you have all of these different APIs backed by microservices that you then have to maintain. And again, it's great because you get exactly the data that you want back, right? That works really well. The problem, though, is now you have all of these different APIs backed by microservices that you now have to maintain. So anytime there's a change, you have to go update everything else in the system. And I would now like to introduce GraphQL, which is the glue for composable commerce, and it's the perfect complement to REST. What is a graph? A graph is multiple points and the connections between those points. And I'm sure the mathematicians out there are screaming at me because I'm not accurately representing graphs. But think of graphs as, flights, for example, between cities, or your friend social network graph, or think of them as subway stops, for example. Those are all examples of graphs. You have individual points, and then you have relationships between those points. And GraphQL is a query language, right? Which is why we get QL there for APIs. So what you can do with a GraphQL query is you can define the query in the middle here, where you say query product ID equals 1001, and then you can request exactly what is required. So you can say, I would like the brand icon URL, the name, the price. And behind the scenes, those are actually coming from different APIs. But the GraphQL server deals with all of that complexity behind the scenes. What matters is that the client is making a request for the data that it needs without regard to how that data is retrieved. But the client makes the query in almost the same way that clients make queries back to relational databases, right? They request through a SQL query what is required. And then the GraphQL server on the server side makes all of the calls to the respective APIs. So think of GraphQL as a layer on top of REST. not a replacement for REST. Facebook originated GraphQL. They open sourced it then in 2015, and they maintained control until 2017. And they then established the GraphQL Foundation and donated that to the Cloud Native Computing Foundation. So that it's actually its own top level CNCF foundation, which is a really big deal in our space. That just shows its popularity. So Facebook originated it, but now is, and they're still involved, but it is very much a community initiative at this point, not just a Facebook initiative. And this is an example of a query. So just to get some terms out there. So you have your operand, and a query could be, query is one where you're retrieving data, but it could also be a mutation, for example, where you're changing data. And then you have your query name, which in this case is just a simple product. And then you have an argument, any number of arguments if you'd like. And then underneath there, you have field names. And the output that you get is always a perfectly formatted JSON object with exactly the data that's required. And you can get as complicated as you'd like with these queries. And again, this is how GraphQL works on top of REST. So within the query, there's a field, and that field maps back to a resolver function on the server. So name right there on the top maps back to a name function in the bottom. And in the bottom, that's where you actually make the API call. So you know then where that data is, you make the call, and you return the product name only. So the resolver is where GraphQL meets the REST API that you're calling behind the scenes. And what's nice is all the messy stuff around authorization, authentication, anything security related, all of that stuff gets pushed to the GraphQL server layer. And it then deals with that data, not the clients. Because if you have 5 or 10 different clients out there, each rendering a product detail page for different devices, you'd hate to have all of that logic duplicated 10 different times. Now it's just exists in one place, one time. And instead you have the ability to very easily retrieve this data through GraphQL. Again, GraphQL is a specification, and that's a big differentiator for it. It's a very, very lengthy document. It's 216 pages when fully printed, and it's very comprehensive. So there's all sorts of text in there around white spaces and line terminations and naming conventions. It gets very, very, very detailed. And that's a good thing because it allows for interoperability. So as long as you conform to the specification, there's this giant GraphQL world of tooling, and there's a giant ecosystem out there that your software can work with. But the key is that everyone adheres to the same basic specification, the same basic rules. I mean, think about it like driving on, on roads, right? If everybody had their own rules, there would be chaos in the streets. But because everybody stops at a red stoplight, the rules make sure that everybody can get along and everybody drives on the road without accidents. Same thing with GraphQL. There's a beautiful, full specification. Everybody adheres to it. That allows for everybody to work well together. There's some things, though, that are not in the specification, and that's deliberate. So things like clients, again, you don't need much for a GraphQL client, but you do need something. There's also the matter of combining schemas. So let's say, for example, you have a commerce and you have a CMS GraphQL endpoint. So now you have 2 endpoints. There is the ability to combine those 2 into one, where you just have one schema that you surface to your clients. And then from that one schema, you can actually call data and retrieve data from both schemas behind the scenes. Security is largely outside of the scope of this. So anything around authorization or authentication with GraphQL. And then finally, caching. And these 4 areas are where the commercial GraphQL servers really shine. That's what allows them to provide differentiation and value in the market. I also want to highlight GraphQL's superpower. It's graph orientation, right? It goes back to the name of it. And what's nice here is you can define a customer type, and then you can define an order, right? And you can retrieve the orders. But they can reference each other. So you can call customer.orders or order.customer, right? It's graph orientated in its nature. So you can very easily traverse data back and forth. You can work your way through a graph very, very easily. And especially if you're working with JSON, which you are by definition with GraphQL, it becomes very easy to do these, change these relationships. All right, GraphQL is the glue, right? That's what makes Composable Commerce work. The two major benefits that it gives you with Composable Commerce is easier front-end development and faster performance. So what's nice about front-end development is your client developers, so people building your mobile applications, your websites, your PWAs, your kiosks, they only have to know about the GraphQL server and authenticate with that server once. And then everything else becomes immediately available to them. So they have full introspection. They're working with an actual specification, and they can very quickly see what types are available, what fields are available, and they can compose their own queries very quickly and very easily. So it dramatically simplifies front-end development by removing all of that complexity from them. And then clients just simply have to query for the data that they want, and then the GraphQL server retrieves it. And then finally, it's faster performance. So with GraphQL, you're doing one HTTP request at most to render any given page. So let's take a big web page, like a product detail page. Before GraphQL, you might have to call 5 different REST API endpoints. And if you're calling 5 of those endpoints, sometimes those have to be done serially. So you have to call one and the other, and then maybe you can call 2 in parallel. But the point being is you're calling these very frequently and in a very serial fashion. With GraphQL, you make one query for all of the data you need to render that entire page. And then the GraphQL server on the server side is calling all of the APIs. And then it's retrieving everything with microsecond latency, assembles the response back, and then it pushes that back to the client in one response. So by doing that, you are dramatically reducing the amount of data that's going back and forth. And also you don't have the issue of synchronously calling multiple APIs at once. So you just retrieve everything in one request. Well, with that, thank you for joining my session. I hope this helps you understand why GraphQL is the glue for composable commerce. Thank you.